Hi, good morning everyone. Today we are going to continue with the implicit differentiation. We are going to focus more on the second derivative and the tangent line. So let's take a look at question number 1. So we're given a dy dx, and dy dx is derivative of the function y equal f of x. Part A, find the second derivative at the point 1, 3. So before we find the value, we have to find the second derivative. So refresh our memory. The second derivative is a derivative of the first derivative. So we have to begin with the first derivative. And then we're going to take a derivative of this. So this is a product, so we're going to use product rule. So u prime, derivative of y is always y prime. Subtract derivative of number 0, simplify it, so we get y prime. And v prime, derivative of x squared is 2x, derivative of 1 is 0, so v prime equal 2x. So the second derivative is a derivative of this, so we have to use the product rule. U prime v plus u v prime. You have to remember this formula. So now we are going to do substitution. So we had y prime times a v. V is a binomial, so we put parentheses. And then u is a binomial, so therefore we put parentheses and times 2x. We do not want to leave the y prime in the answer, and we know y prime equal to this. dy dx is y prime. So we do substitution. We're going to substitute this whole thing by the y prime. So we are going to replace this by y minus 2 times x squared plus 1. This is the y prime. And then we are going to copy the rest. So we don't need to simplify this because we are going to continue to find the value at 1, 3. In our AP exam for a free response, you don't need to simplify. So now we're going to find the value at the 1, 3. So we get x and y. Now we just do substitution. So we get 3 minus 2, 1 squared plus 1, 1 squared plus 1. And then you get 3 minus 2 times 2 times 1. And now we simplify. And then we got 4 plus 2 equal to 6. So we found part A. The second derivative at 1, 3 is equal to 6. Now let's take a look at part B. Part B asks you, is the graph of y equal to f of x concave up or concave down at the point 1, 3? Specify your answer. So definitely part B is related to part A. Let's refresh our memory. For a function to be concave up or concave down at our point, we have to look at the second derivative. If the second derivative is positive at that location, then the function is concave up at that location. If the second derivative is negative at that location, and then the function will be concave down at the location. So now we are going to say, because we found it in part A equals 6 is positive. So y equal to f of x is concave up at 1, 3. So we finished part B. Now let's go to question number 2. Question number 2. So the question said that consider the curve by the equation. Okay, we get 2 times x minus y equal to 3 plus cosine y. For all the points on the curve, we got the interval of the first derivative. dy dx is between 2/3 and 2 inclusive. So part A, you have to prove that, prove it. dy dx equal to this. So now we are going to do part A. We have 2x minus y equal to 3 plus cosine y. Now I do not want to use the plotter rule, so I multiply this out. So now I have this. Next I'm going to find the derivative. So derivative of 2x is 2, and the 2 stay the same. Derivative of y is y prime. Derivative of a number is 0. Derivative of a cosine is negative sine y. When you see y, you immediately put y prime. You have to use a chain rule. So now we're going to solve for y prime. So I'm going to plus 2y prime both sides. Get 2 equal negative sine y times y prime and plus 2y prime. Now I factor out the y prime. I will get negative sine y plus 2 equal to 2. Now y prime equal to 2 over negative sine y plus 2. So if you want to make it look the way it was, all you have to do is swap this order. So now I just swap it. So 2 over it's just 2 minus sine y. So we finished part A. Now let's go to part B. For the interval y between negative pi over 2 and pi over 2 not inclusive, there is a point P on the curve to which the line tangent to the curve has slope equal to 1. Find the coordinate of the point P. So now that means the slope equal to 1, and that means the derivative equal to 1. We're going to use our derivative to find the x comma y. So now for part B, m equal 1. So dy dx equal to 1. So we got 2 over 2 minus sine y equal to 1. So from here we can solve for y. So cross multiply. So I'm going to get 2 minus sine y equal 2. Subtract 2. Negative sine y equals 0. Divide by negative. I get sine y equals 0. Sine of what value equal to 0? We know that sine 0 equal to 0. So we know y equal to 0. But if you hear nothing of this, you just had to use another way. So you just let theta equal to y. So sine theta equal to 0. Find theta. So now we look at the graph of the sine function. And then from the negative pi over 2 to pi over 2, then you only can have one value. So at theta equal to 0, sine theta equal to 0. So we found that theta equal to 0. So y equal to 0. The same answer as you got before. You just think about sine of what value equal to 0. So we found y value. So next, just find x. To find x, you always use the original function. So let's go back to the original function. So we got 2 times x minus y equal to 3 plus cosine y. Now we are going to substitute this. 2 and then we simplify. And we know that cosine 0 equal to 1. And then you get 2x equal 4, and then x equal 2. So point P is 2, 0. So we found the answer for part B. Now let's take a look at part C. For part C, determine the concavity of the curve at points for which y is between this interval, negative pi over 2 and pi over 2. Give a reason for your answer. So the keywords will be concavity of the curve. So we had to use the second derivative. If the second derivative is positive, the function will be concave up. If the second derivative is negative at the location, that will be concave down at the location. So now let's find out the second derivative. So we got dy dx equal to 2 over 2 minus sine y. Because the numerator is a number, I do not want to use the quotient rule, so I'm going to rewrite. So dy dx equal to 2 times 2 minus sine y to the negative 1. And then I'm going to use chain rule. Okay, so because of space, I'm going to write over here dy dx equal to 2 times. So now I'm going to use a chain rule. So coefficient 2 stay the same, exponent, bring it to the front, negative 1 minus 1. And then you're going to copy down this part. And then immediately you multiply the derivative of 2 minus sine y. If you need a little bit space, you can write over here makes u equal to 2 minus sine y and find the derivative of it, and then substitution. Derivative of 2 0 minus derivative of sine y will be cosine y times y prime. So u prime will be negative cosine y times y prime. Now I'm going to substitute it. And then we simplify a little bit. I'm going to rewrite this into a fraction. And this will be negative cosine y times y prime. So we know that we're not supposed to have a y prime over here, so we're going to substitute the y prime. This is the y prime. Okay, so we're going to substitute. You're going to simplify. Negative times negative is positive. 2 times 2, 4, and multiply the cosine y, because cosine y over 1. And this is going to be the same. And then 2 is exponent, and over 1, so 3. So we found the second derivative. And we want to see if this is going to be concave up, concave down. So we look at the interval. Okay, negative pi over 2 to pi over 2. They already gave us the interval, and they said that the points over there are going to be concave up or concave down or not. So you definitely just have to check one point, because all the points over there are going to follow the same pattern. So we just have to pick a y value, any y value. So let's y equal to 0. That'll be the easy one. So my second derivative at y equal to 0, that will be 4 times cosine 0 and 2 minus sine 0 holding to third power. We know that cosine 0 is 1, and then sine 0 is 0, and definitely this is going to be positive. Okay, so the curve on the interval is concave up because positive. So we finished part C. Let's go to part D. Part D. Let y equal to f of x be a function defined implicitly by this that is continuous on the closed interval 2 to 2.1 and differentiable on the open interval 2, 2.1. Use the mean value theorem on the interval 2, 2.1 to show that this is true. So this part is giving us that the condition of the mean value theorem. So if these two are true, then definitely the mean value theorem is true. So some people may want to refresh the memory about mean value theorem. So is that if f of x is continuous on a closed interval and differentiable on the open interval, then f of b minus f of a over b minus a equal to f prime of c, and c is between a and b. That is the mean value theorem. So if you look at here and the information, so that means I should write f of 2.1 minus f of 2 over 2.1 minus 2 equal to f prime of c. So this is the slope equal to the derivative. And c is any point between a and b. So c is between 2 and 2.1. And how do I get from here to here? This is the slope or the derivative. So now let's take a look at in the beginning. There's one more piece of information that you haven't used. Look at this part over here. This part caught our attention when we read the question. They gave us the range of the derivative. dy dx is between the 2 and 2. So over here, we say f prime is c, in fact, is the dy dx. And where c equal to x. So now that means if I know dy dx is between 2 and 2, I can just say this part is between 2 and 2. Do substitution. Okay, this go in here. Okay, so now I can say because this is the slope. Now I'm going to use algebra to simplify it. So I get 2 less than equal to this. This becomes 0.1. And if I want to cancel the 0.1, so I have to multiply each by 0.1. Then this cancel out. So I get and I want to have a fraction, so therefore I put 2 times 1/10. Okay, we're almost there. So now to simplify it, you got 2 over 30, that is 1 over 15. (210), and then you simplify into 1/5. So we finished the question. And I want you to go to video number 2 to take a look at how we do number 3.